Okay, so yesterday I asked you to so in this video we're going to talk about functions, but before we talk about functions, we need to know what a relation is. A relation basically just takes a set of inputs, a set of x values, and relates them to a set of y values. So anytime you have a graph, or you have a table, or you have some points, or you have a mapping diagram, which we'll see later in the video, that's a relation. Anytime you represent x values and y values this way, you have a function, or you have a relation. So a function is a special type of relation where each input has only one output. So what I'm basically saying is that if you have the point 3, 6, 3 can only be related to 6. 3 can't also be related to 8 because in order for it to be a function, each input has to have its own output. Think of it almost like a relationship. If you're 3, you really shouldn't be dating 6 and 8 at the same time. That relationship won't function. So this would not be considered a function because the input 3 has more than one output. Something important to note is that we're only talking about inputs. So if I have the point 6,9 and the point 8,9, this is actually totally okay because we're only looking at the inputs. The inputs are both different, so it's okay that they have the same output. We're talking about each input only having one output. Just so you guys know, there's a couple words that we use in this unit that are synonymous. So the words x, independent variable, input, and domain are always talking about the same thing. So independent variable is the same thing as the x value, and the input is the same thing as the independent variable. And then this set of groups also mean the same thing. So y, dependent variable, output, and range all mean the same thing. So you can really use these words interchangeably, except for kind of domain and range, because domain and range end up talking about a group of numbers. So domain and range is almost like the plural version of the other three in each group. So I like to talk about function or na. So automatically, this is a relation. I have a set of inputs and I have a set of outputs. So automatically, I'm relating the two, so it's a relation. But what I want to know, is it a function or not? So what I do is I look at each of my inputs. I have an input of 5, an input of 8, an input of 10. 5 is dating 9. 8 is dating 4. And 10 is dating 9. None of these inputs is dating more than one output. So this is a function. This relation is a function. Is this relation a function? Again, I'm going to look at my inputs. 1 is dating 10. So that's good. But look here at 3. 3 is dating 2 different outputs. So that automatically breaks our rule of what a function is. A function has to have one input related to one output, but 3 is related to 2 outputs, so this is not. Also, this is what a mapping diagram is. All a mapping diagram does is show you what input is matched with one output. So you just follow the line from the input to the output to tell which two numbers are related. Okay, so this is a relation. It's a group of x and y values that are related to each other. So 3 is related to 7, 10 is related to 12, 13 is related to 8, and as you notice, none of our inputs are repeated, so this is a function. So I look at my table and I check out my input column, which is again synonymous with x, and in my input column I find a big no-no. 8 is dating 15, and 8 is dating 17, which is not allowed, so this is not a function. We've looked at 3 of the 4 different types of representations of functions in the past couple examples. We've looked at mapping diagrams. We've looked at tables, and we've looked at ordered pairs. What we haven't looked at is a graph. So the vertical line test is used for graphs. And basically, if a vertical line touches more than one place on a relation, it will not be a function. So let's look at this one. If I draw a vertical line anywhere along this function, and the function is the green object, if it touches more than one spot, then that means that it's not a function. I can draw infinitely many vertical lines. I could draw a vertical line anywhere here, and it's not going to touch the function at more than one spot. Therefore, this would be considered a function because it doesn't touch the green at more than one place. This obviously is not a function because when I draw a vertical line, it touches the green at 2 places. The reason the vertical line test works is because say that this right here, say that this coordinate is -1. So the x coordinate is -1, and then say this coordinate is 2, this y coordinate's 2, and this y coordinate's -2. What's happening here is that the coordinates of this point would be -1, +2. And then the coordinates of this point would be -1, -2. So you can see that -1 is associated with 2 different outputs, which violates our definition of a function. So that's why the vertical line test shows us if something is a function or not. This would be not a function. So domain and range, I talked about it briefly before. They are the set. They're both sets of values. So there's going to be more than one value in a domain and more than one value in a range. So you can't just call one number a domain, or you can't call one number a range. We're really talking about a group here. Domain is the set of input values. So domain, which has in it, is the set of input values. Range is the set of output values. I don't really have a great way to remember that. That one's really up to you. So in this function, my domain is going to be my set of input values. So my domain is going to be 1, 2, 3, and 4. And this is the way that I expect you guys to write your domain. You write D and then a colon and then the brackets. If you can't draw a curly bracket, this is completely fine. And then you write your values. Range is the set of output values, so this function has output values of 7, 8, 9, and 10. And that is an 8. So the last thing we need to know is function notation. So f of x means, it's basically the name of the function. It means that f is a function of x. And so f of x and y mean the same thing. Those are synonyms, f of x and y. So f of x, when you see it, should be associated with your outputs, because f of x and y are the same thing, and y is outputs as well. And so if you ever see an equation that says y equals 3x plus 1, you can always rewrite it as f of x equals 3x plus 1. The reason that this is helpful, the reason that we might choose to write it this way instead of the first way, is because this shows what x is. So for instance, if I wanted to plug, say I wanted to plug in 4 for x to figure out what comes out when I plug in 4. I would plug in 4 for x in both places. So this says f of 4. So what is the function when x is 4? Well, f of 4 is going to be 3 times 4 plus 1, which is 13. So right here in this notation, you can see that x is 4 and your output is 13. So you might be given a problem that says h of x equals 3x plus 4. This letter changes a lot. We see f of x because f stands for function a lot of the times, but you really can use any letter here. And so it's going to change often, and you kind of just got to get used to that. So if you're given domain values and you're asked to find the range values, the domain values are associated with x. So really what we're going to be doing is replacing x with these 3 values. So the way that I would write that would be for the first one, so when my input is -1, when I replace x with -1, I'm going to write h of -1 equals 3 times -1 plus 4. So I'm basically replacing x with -1. And then I evaluate it to see what I get. 3 times -1 plus 4 is 1. So h of -1 it equals 1. So when x is -1, your output is 1. So I'm going to put 1 in my range because -1 and 1 are related. Now I'm going to plug in, instead of -1, I'm going to plug in my next input, which is 3. So instead of putting in -1 for x, I'm putting in 3 for x. So I do 3 times 3 plus 4, which is 13. So when when x is 3, h of 3 is 13. So I'm going to put 13 in my range as well. And then the last value that I need to plug in is 4. So for x, I'm going to replace x with 4 and see what I get out. So when I put in 4, 3 times 4 plus 4 is 16. So h of 4 is 16. And so 16 goes into my range. So when these are my domain values, 1, 3, and 16 are my range values.